Okay. So here I have the Earth, which I've taken a lot of flack for my drawing so far.
Yeah, he threw a pen at me.
I did throw a pen at one of my... No, I would never do that. It would be uncommon. So I have the center of the Earth here, and a radius r for the Earth. And then I have this little x distance is supposed to be, like if you zoom in on that feature there, that's a ship with a thing, and a little doohickey up here, and a guy.
Crow's nest. Wait, is that an anchor?
Wait, the point is?
Ship.
There we go.
Ship, sail, mast. Poor doofus whose job it is to climb up there and sit in the part of the ship that sways the most.
So the X is how tall the ship is.
So the X is basically the height of the ship.
Which
Yeah.
is very unproportional to the actual drawing of the Earth, but
Whatever. Okay. So they want me to find formula for distance d, you can see to the horizon, and L, the distance to the horizon along the Earth's surface, in terms of x, the height of the ship's mast, and r, the radius of the Earth.
Whoa. Do we have to flip that little?
Okay, so let me pull this whole triangle out.
That whole one out.
So I'm going to pull out this right triangle. You guys all with me that that's a right triangle?
Right
Very
triangle.
positive.
Why is that a right triangle?
Because the radius and the horizon intersect perpendicularly.
Has an end.
Yeah.
Is it a tangent line?
Yeah, it's a tangent line because if you're looking at a ball, right? And
Any flat surface across
so
the
if
ball.
you're kind of standing on this ball looking, right? Unless that's the very last point you can see, you can always look up a little more, right? So unless that intersection is actually a right angle, you can look up a little more and see a little more. So if I pull that right triangle out, it looks like this. Oops, not like that. It looks like this. This hypotenuse is r plus x, right?
Yep.
There's a right angle here. This is r, and this thing across here is
D.
d. Okay, so I think I know that d squared plus r squared is r plus x quantity squared. Right? So I think I get that d is the square root of r plus x squared minus r squared.
Yep.
Okay, which I could massage a little bit by squaring out r plus x squared.
But R and X are given.
So they didn't tell me that in part A. I haven't read that far.
Oh.
So that'd be r squared plus 2rx plus x squared minus r squared.
So then it's just
Yeah.
2rx.
So all told, I think my answer for A is D is the square root of 2rx plus x squared.
Which is the distance that the guy sees until the horizon.
Yeah, so that's how far the guy can see in terms of the radius of the Earth and the height of the ship.
Yeah.
You guys all good with that?
Uh-huh.
So what was the trick there? Because that's worth noting.
The triangle.
Yeah.
Pythagorean theorem.
Draw your picture and then pull a triangle you know about out. Don't try to do math in the picture. Like pull those triangles out and fiddle with them out.
Okay.
It makes life a lot easier for some reason. I think it's mostly psychological, but it works. Okay, so wait, did I not do part A? Find formulas for D, the distance you can see to the horizon, H, and L. Oh, I see. I didn't do the parts about H and L, right?
I think it's D and it's L. And then
Oh,
D
and
is
L,
like in
yeah.
terms of-
Because there's not going to be a formula for H, right?
Right.
Because H is just a point. But there's a formula for L, which is like,
Curve.
that's how far you'd have to walk, right?
So that would have to be in like
You
radius.
guys see that? So D is the distance you can see, and L is the distance you'd have to actually go to get there.
L is an arc.
Yeah, so L is an arc.
And then r.
So
is
I think what I need to know is something about L. So L is
r theta. R times theta.
R, the radius, times theta, the angle in there,
in radians.
in radians. Okay, so where do I get the angle theta from?
that's, well,
Isn't, that's a standard triangle, right?
Okay. This is a right triangle.
But do we know if it's a 30, 60, 90?
I don't know that it's a standard triangle.
You can use like log, cosine.
Oh, probably easier. It's a right triangle.
So you can just
So theta's in here, right?
So you just use cosine instead.
Yeah, and I'd probably use cosine
Yeah.
because r and r plus x are probably the simplest I'm going to get. D was kind of annoying, right?
Mm-hmm.
So I probably don't want to have that in there.
Okay, so they're
So I want the adjacent hypotenuse. So let's see. So theta, cosine of theta at least, is what?
equals r over x, r over r plus x.
R over r plus x.
So cosine inverse equals theta.
Okay, so theta is the cosine inverse of this thing.
Yeah.
So I think L then is r times the cosine inverse of r over r plus x. You guys with me on that?
Yeah.
Okay, then part B, how far is the horizon from the top of a 50-meter mass?
Let's just plug in 50 for x.
And it tells me that the radius of the Earth is 6,370,000 meters.
Wow.
Alright, so you add those
So
to
you
50,
just-
make that the hypotenuse.
Okay,
and
so
then just
do some calculations.
Mhm.
I trust that you guys can do part B pretty easily.
Okay.
So, moral of the story, draw your picture nicely and then pull your triangle out. If you're pulling out more than one triangle, I really would recommend that you get a couple colors and color code which triangle you're talking about by just kind of decorating that triangle. So there's a blue triangle. I'm going to pull that triangle out. If this other triangle up here that isn't a triangle, you see that? Like if this triangle was interesting to me, I would color code that red and then pull it out and draw it in red. Or add a little, like a little squiggle of color next to this thing to get that sort of sorted out and organized.
Okay.
Cool?
Yes.
I think
Right.
this is a pirate ship.